Okay, so let's solve another example with general approach. So we have the differential equation, we know y1. So we know the next step is y is u times e to the 2x. So let's find y prime. So we have to differentiate this and you have to use product rule. Differentiate u, you get u prime, keep e to the 2x unchanged. Now keep u unchanged. If you differentiate e to the 2x, you get 2u e to the 2x. Okay, now you need y double prime, so you have to apply product rule here. So u double prime e to the 2x plus 2u prime e to the 2x, that is by differentiating e to the 2x. Now again you apply the product rule here. 2u prime, I differentiated u e to the 2x. Now it is time to differentiate e to the 2x, which you get 4, another 2 comes out, u e to the 2x. Okay, make sure you do the product rule very correctly, okay, otherwise you will be in trouble, you see. So let's substitute them into the differential equation, but first if you add these two, this is just 4, we can reduce the number of terms and this term goes away. Okay, so let's substitute them. U double prime, y double prime, u double prime e to the 2x plus 4u prime e to the 2x plus 4u e to the 2x. Now what should you anticipate? U is going to cancel out, right? So know that in your head. 4 times y prime is this term, u prime e to the 2x minus 8u e to the 2x when you distribute negative 4 here, plus 4 times y is u e to the 2x. So let's see equal to 0. So let's see whether we get u cancelled out or not. Otherwise I have done a mistake. Negative 8u, 4u is all together 4u, 8u minus 8u is gone, right? It should happen definitely, okay? So e to the 2x u double prime plus here 4u prime minus 4u prime, a bonus. Here we go, this term also cancel out. Yes, that makes our equation very simple, right? That term also cancelled away. We were lucky, equal to 0, okay? Good, we have a very simple differential equation. What is the next step? Well, we can divide by e to the 2x, really, right? Assume e to the 2x is not 0. Of course, it's not 0, right? It's never 0. U double prime is equal to 0 when we divide by e to the 2x. Then we make a change of variables. What is it? W is u prime. So if w is u prime, u double prime is w prime. So the equation actually is w prime equal to 0. Now w prime is dw over dx equal to 0. So it's just we can take dx to the other side. So if we integrate here, what do we get? If you integrate left, you get w. If you integrate 0, you get a x, right? No, a constant c1. If you integrate 0, you get a constant. Derivative of constant is 0. So integral of a 0 is constant. That is w. Now what is w? We are shooting for u. W is u prime. We are not yet done. So if u prime is c1, to get u, you integrate this once more, right? So what is u? If you integrate a constant with respect to x, so u prime is du over dx is equal to c1. So du is actually c1 dx. So if you integrate, here you will get u. If you integrate a constant, you get c1x plus another constant. So this is c1x plus another constant. Okay, so now we can choose our values to our own values for constant. Let's choose c2 to be 0, c1 to be 1, just for simplicity, so that we can get nice function u is equal to x. Don't ever take like c1 is equal to 0, okay? So then the function vanishes, okay? That doesn't make sense. So u is x, okay? We are almost done. So y should be u times y1. So y1 I remember e to the 2x. So u is x. Y is e to the 2x. Okay, this is our second solution. Y2. Now let's add that subscript. Y1 is e to the 2x. Y2 is x times e to the 2x. These two are linearly independent. They look like similar. I know, wait a minute. E to the 2x and x times e to the 2x are linearly independent. They look like same. But see, e to the 2x is multiplied by x. X is not a constant. If you have a multiple of a constant multiple of a function, then they are linearly dependent. But these two functions are multiple of a function, then it's independent, okay? Then it's not linear relationship. So the final general solution is y is equal to c1 e to the 2x plus c2x e to the 2x. So this is the general solution for the differential equation. Okay, all right, and yeah, see you in another example video. Thank you.